Today we'll be talking about reference angles. You can read here on the slide the definition of a reference angle. If theta is in standard position, the reference angle is acute. I'm going to highlight that. It's an acute angle, and they call it theta prime to show that it's related to theta, but different. And it's formed by the terminal side of theta, so where theta ends, and the horizontal axis, otherwise known as the x-axis. And one little note here, one thing I'd like to note is that these reference angles are formed to the closest x-axis. We'll show you what that looks like in just a little bit. So here you have some really nice pictures of the different quadrants and what the reference angles would look like. So obviously in quadrant 1, they're already acute. So they really don't need an angle, a reference angle. But quadrant 1 is full of reference angles. That's all there are in quadrant 1. Any angle in quadrant 1 is its own reference angle. Now in quadrant 2, you can see that you have a terminal side here, somewhere in the second quadrant. So the reference angle is going to be this distance to the horizontal axis or to the x-axis. But we don't want this reference angle. We want the closest angle. So for example, if this were 160, then the reference angle would be 180 minus 160, or 20. Here in the third quadrant, quadrant 3, you can see that we go past the 180 degree marker, but still the closest reference angle is going to be this negative part of the x-axis, not the positive part of the x-axis. So this will be the original angle, say it's 210 minus 180 degrees. And the reference angles are positive, which is helpful. Over here in the fourth quadrant, let's label that. The closest horizontal axis is the positive x-axis. So here, let's say you had the theta of 300, your reference angle would be 360 minus 300, or 60 degrees. So here, we just did that example. We would say 360 minus 300, and we're going to see these on the next couple slides, the solutions. So I'm going to go ahead and fast forward. It says here, because 300 lies in quadrant 4, the angle that it makes with the x-axis is here, and therefore 360, or this positive x-axis, and I'm actually going to take a quick second and highlight that. Right here is where we're measuring the reference angle. So our reference angle would be 360 minus the 300 equals 60. And you can see theta prime is 60. The second example, they gave us theta equals 2.3. And recall when theta does not have degree symbol, that means that it's in radians. So I'm going to label this up here as radians. Now, if you think of pi being 3.14, and pi over 2 being about half that, or 1.57, 2.3 falls somewhere over here in quadrant 2. But our reference angle will need to be in radians because our original angle, theta, is in radians. So we would say pi, right here, I'm going to highlight that again. I think it's helpful to see where we're talking about. The closest horizontal axis is here, the negative x-axis, which is where we have pi. So pi minus 2.3 is about 0.84, which is your reference angle. And finally, they talk about negative 135 being theta. That's our theta. And remember, when it's negative, it is going in a clockwise direction. So here you can see theta is negative 135 in the direction. But that is in quadrant 3. And so again, our closest horizontal axis is going to be the negative horizontal x-axis. So we'll go from 225 minus 180 is 45. It helps to know this concept of a coterminal angle in this instance. 135 might not be very helpful, but knowing that negative 135 and 225 are coterminal helps you to find the reference angle a little easier.